Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the polytropic process. During actual expansion and compression process of gases, pressure and volume are often related by P(V)N equals C, where N and C are constants. A process of this kind is called a polytropic process, where constant N is called the polytropic index. During a process, N keeps unchanged, and characteristics of process are determined. For different polytropic processes, N is different. Let's first talk about the expansion work. Suppose the process is quasi-equilibrium process without friction, and the work is for 1 kilogram of working fluid. The pressure for a polytropic process can be expressed as any expansion work by definition can be expressed as for any exponent n except n equals 1. When n equals 1, the process is an isothermal process and the expansion work is, which have been discussed before for isothermal process. Secondly, let's talk about the technical work. Since the technical work is n times of the expansion work, we have this relation. Thirdly, let's talk about the process equation. Comparing the polytropic process formula with the isentropic process, we can find that as long as the specific heat ratio in equations 827 to 829 is replaced by the polytropic exponent n, the polytropic process state parameters can be expressed as. Fourthly, let's talk about the PV diagram. In the PV diagram, the polytropic process is a cluster of curves that changes with n. If the polytropic process is drawn on the log P log V diagram, all the polytropic processes are straight lines, and the slope of each line is exactly equal to the negative value of the polytropic index. Fifthly, let's talk about the TS diagram. In the TS diagram, the polytropic process is also an exponential curve cluster that changes with n. By definition, the polytropic specific heat is. If the polytropic specific heat is fixed, then we have expressions for S or T. These equations show that if the polytropic specific heat is a fixed value, then the polytropic process is a cluster of exponential curves in the temperature entropy diagram. In the TS diagram, the distribution of the polytropic progress line also starts from the isentropic lines, and the polytropic index n increases in a clockwise direction. For an ideal gas, the relationship between the polytropic specific heat and the index is as follows. Okay, that's all for this task. Thank you very much, and see you next time.